This conference will now be recorded.
Hello everyone. We will be starting off with the System Verilog for Functional Verification course. Today is the first session of the course. Uh, Today we will be starting off with the basic overview of System Verilog and how it differs from Verilog, and a very basic introduction to object-oriented programming in System Verilog. So first, let us start off with understanding the course prerequisites. Before you start System Verilog course, you should be familiar with how to use Verilog for design and verification purpose. At minimum, you should be familiar with what is task and what is a function. You should be familiar with what is arrays and what is a vector. Let's say if I tell you uh, define an integer array, define a vector, you should be able to do. You should know how to work with arrays and vectors. Then if I give you a simple module, you should be able to do the module. Then you should also be develop the simple test benches, like how to generate the scenario, how to do dollar display, those kind of things you should be familiar. Then you should understand the concept of test case. Like in memory test bench in Verilog, we have developed various test cases like front door write, back door read, various combinations we have developed. Those kind of concepts you should be familiar. Other than that, you should be familiar with the basic operators, like what is meant by assignment operators, comparison operators, those kind of operators you should be good with. Other than that, you should have a working knowledge of GVim or Notepad++. Other than that, you should be comfortable with any one simulator, like how to use model sim. Uh, you should be familiar with the EDA playground, and this is, if you are not still not familiar with this, we are going to teach this how to use EDA playground. Okay, so these are the course prerequisite. Some of you who have completed Verilog course and who are joining System Verilog course, if you are not comfortable with Verilog, please do not join System Verilog. I suggest you to repeat Verilog in that case. Okay. With not having proper understanding of Verilog, if you do System Verilog, you will find it very difficult to cope up with the course. A course will have around 16 assignments. All are focused on the practical uses of the language constructs. Will gain a good expertise on system Verilog. If you can just complete this 16 assignments, you will become expert with the system Verilog. Towards the end of this course, there will be an evaluation test. Based on that, you will be promoted to the next level of training. And even if you're looking for a certificate, that will be issued based on the performance in the evaluation test. Next, as you know, course material will be available on our e-learning portal, where you will get access to the presentations, notes, labs, and assignments and everything. What is the expectation from student? You should complete assignments as scheduled. Be proactive in the session, because most of the people here are attending online. So please be proactive in the session. Respond during the sessions, and make the sessions interactive. Now, let us start off with understanding of the functional verification overview. Uh, I think no point going to this level, because this would be, I would rather start off with the system Verilog basic concepts. Wait. So just give me 1 minute. I'm just, let's directly start off with understanding the system Verilog course objective. I mean, what is the intention? What all things we are going to learn as part of the course? Uh, First, let's start with the course overview. Course will be for at least 8 weeks duration. During this 8 weeks, initial 1 week, the first week will be focused on the system Verilog data types, basic data types, operators, and arrays. the second week. Okay, first week and the second week. The second week onwards, I mean, see, this mid of second week till fifth week will be on object-oriented programming. Then sixth week will be focused on sixth to seventh. I mean, sixth to eighth week will be focused on other advanced topics like coverage, sessions, inter-process synchronization, fork join, various topics after that. Okay, you see, we give a lot of emphasis for object-oriented programming. The course, the way it is been organized is the first 1 2 weeks are focused to learn the system Verilog data types and operators and arrays. Later, we move to object-oriented programming. Once we are done, then we move on to the other advanced topics. Okay. So first, let us start off with the understanding of course objectives. Can you please read this one, everyone?
Sir, whatever the schedule that you're telling is for a full week or weekend patched
It's a
schedule.
full week schedule. Please read this. I'll just be back in a minute and I'll explain. Okay, so I hope you have read through this. Basically, the objectives will be learning all the system Verilog language constructs. For every construct, you should be able to write simple test cases to check each construct uses. Exposure to on-chip protocols, like you should have you as part of this course, you will learn AXI, AHB, APB kind of protocols, and you will also get some basic protocol overview. Then you should learn how to develop verification IP for a given protocol. Then you should also learn developing the system Verilog based test bench from scratch for a complex design, like coding the test bench components, test case coding and debugging, setting up regression and analyzing the regression results. Now, this whole learning will be spread over 3 months' time. So you don't need to worry, even if you don't know how to do this, you don't know how to do this, you don't know these things, don't worry, everything will be covered from scratch. Now, someone had a question, you can ask your question now.
Yeah,
Question regarding the schedule.
yeah. I was just thinking like it's a full week course or weekend, like weekend, whatever the schedule that you're mentioning now.
Basically, the full week course will be 6 days per week, 4 hours per day. And Sunday is off. If you are looking for a weekend course, it will be 2 days, of course, the Saturday and Sunday. Again, there will be 4 hours per day. Remaining 5 days, I mean, you get access to all the recorded videos for viewing, for watching during the weekdays. The plan. Now, do you further have any questions regarding this schedule?
Yeah, so the full week course means it's online or offline classes.
Both is there. Both. This is available online and offline. It's
How
also
many
available
hours do you
online.
teach in week
How many hours?
per in a like in a weekday course generally?
24 hours per week, right?
No, no, no. I'm just saying like how many hours do you teach per day?
Do
So will there be
do
any
you need
like from 9 to 3 something, 9 to 12 something like that?
like that? No, no. See, I
Schedule.
told you, right? 4 hours per day. Schedule could be mostly 9:30 a.m. to 1:30 p.m. kind of schedule, or 2 p.m. to 6 p.m. kind of schedule.
Okay. Okay.
In the weekend course, it will be 10 a.m. to 2 p.m. schedule.
So the fee would be same,
Basically,
right?
sorry,
The fees is same, is that?
fees is same. Yeah. See, the thing is,
Okay.
here you are getting access to all the recorded videos that you can watch during the weekdays. Here, you attend all the live sessions. This is a different track. This is a different track. I mean, there is a you don't attend this lecture. These people don't attend this lectures. So they run as a different tracks. Any other questions?
No. No, thanks.
Uh,
Thanks a lot.
okay, our system Verla course is quite elaborate. Uh, because we believe that system Verilog is the foundation for whole verification. I mean, test bench development, anything. System Verilog expertise makes UVM learning easier. I mean, if you are comfortable with system Verilog, right, you can easily learn UVM. So, hence, we give a lot of emphasis. Sometimes what happens, this 8 weeks even goes to 10 weeks also, or 10, 12 weeks also. We don't mind, because the main goal of the course is to that you should learn, not that we should finish it in 8 weeks or we should finish it in 7 weeks. Main focus will be to make sure that you do the assignments and you learn as much as possible from those activities. I'll just give you a brief about how the assignments will be. These assignments are quite elaborate assignment. I mean, any topic you take, let's say if I take assignment on array, queue, mailbox, and declaration, the assignment would be in a very detailed manner. It won't be like just do this one line. It will tell you what to do step by step also. And then more importantly, you get guidance for each and everything. Let's say for every question you are doing, there will be a live session where the trainer will be providing you the guidance for each and every question. All that you need to do from your side is you should be proactive and you should be trying to do these things yourself. Wherever you are stuck, you will get a support. Like that, every topic you take, for example, if I go to class, it's a very elaborate course actually, elaborate assignment which runs into almost 30 pages, 15 or 16 pages, which covers everything of object oriented programming. Okay. Now let us first start with understanding why we need system Verilog. System Verilog is required because design complexity is increasing. I mean, whatever with every passing year you see, let's say whatever electronic product you have, the next 2-3 years later this is more complex. Again, after 2-3 years later, it is more complex. What is meant by complexity? More number of features, more complex features, and the complex protocols to implement those features. So to verify these kind of complex things, you need a more complex test bench. Because design is complex, your test bench also should be complex. System Verilog makes this complex test bench development easier. This is the first reason. What is the second reason why we are going for System Verilog? To meet the time to market. What is the time to market means? How quickly we can launch the product into the market. System Verilog has more constructs. Test bench development can be done quickly. Hence, verification can be completed quickly. I mean, System Verilog makes the test bench development easier. Because it becomes easier, so verification process can be completed quickly. The third reason why we are moving to System Verilog is for better project management. I mean, what is meant by better project management? You can reuse the existing code. Whatever you have developed for a previous project, it can be used for the new project. System Verilog is based on object-oriented programming, which helps with the code reuse. The third part of the project management is the project tracking. See, System Verilog has a concept of functional coverage, which helps keep track of the progress we have done with the project. So there are three reasons. I mean, whenever you go to interview, they will ask you these things, right? What is the need for System Verilog? Can someone tell me what is the first reason why we are going to System Verilog?
It has a lot of features compared to Verilog test pen, like hoops
More
concepts.
features, more features makes test bench development easier. So we can complete verification quickly. What is the second reason? Can you tell me? Can someone tell me what is second reason?
Maybe it is like extension of a Verilog.
No, no, we just now discussed. We just now discussed to meet time to market. I mean, yeah, that is time to market only, right? What is the first reason? Designs are getting complex. So test bench development also getting complex. So hence, we need advanced language to develop. What is the third reason? Can you tell me? Better project management. These are the reasons. I mean, this much you should be familiar because this is the first question they ask you in interview, right? When you go to interview, you say that you know System Verilog. What they will ask you? Why we are learning System Verilog? Is everyone clear with this? Why we are learning system Verilog?
So can you tell me what is better project management?
I told you, right? Better project management is what? Reusing of the existing code. You can easily develop the project code by using the existing code. You can even, what is meant by project management? You can easily tell what stage the project is. You can track the project progress. Like if I tell you how much percentage of verification is complete. In system Verilog, you can easily see the numbers and tell I have done 75%. Now I have done 93%. That is easily possible in system Verilog because it has got something called as functional coverage. In Verilog, this concept is not there. Is that clear to you?
Thanks. It's clear.
Okay. Next, running system Verilog code using QuestaSim. Like till now, you are all familiar with how to run Verilog code using Model Sim. Running system Verilog with QuestaSim is no different. It is same as running Verilog code with Model Sim. You have to follow the same steps. You have to create the compilation library using vlib command. You have to do the compilation using vlog top.sv. Okay. I think let me not complicate it too much. Just no need of giving word clip for now. Then whatever compilation you did, okay, whatever compilation you did, you have to map that to the work library map. Okay, even this is really not required. Let me not complicate too much. Okay, after the compilation you do elaboration using object file tool, come up with test bench structure like vsim -no vopt work.top. Basically you are elaborating the top module, then you run the simulation. You see, do you see any difference from the way you ran Verilog code? Those who have gone through Verilog course, do you see any difference between Verilog and system Verilog execution steps? No difference, right? Okay, you can even create a do file. Whatever you did in Verilog, you can do very much the same thing here. Next, now let's get into system Verilog language concepts. System Verilog has two kinds of data types. One is called as static data type, dynamic data type. If you see Verilog, Verilog has only static data type. Only static data types. System Verilog has both static and dynamic data types. Let's try to understand what is static data type and what is dynamic data type. If, for example, if I write integer a, this is called as static data type because as soon as we declared, as when this code is compiled, when this code is compiled, tool automatically allocates 32-bit memory for variable a. What happens when this code is compiled? Tool automatically, see, this is important. The tool automatically allocates how much memory? 32-bit of memory to the variable a. So that tool knows that integer means 32 bits. That is called as static data type. Whereas what is meant by dynamic is, so this concept is called as static. Now what is dynamic is, if I write integer int array, dynamic array, there will be one type of array like this. This is called as dynamic array. Here int a, during compilation, tool doesn't allocate any memory to integer array because since it is dynamic in nature. Only when you do during the code, when you do new of, let's say, 5, now 5 element space is allocated to the memory, to the array. Understand the difference? when you declared like this, no memory is allocated during the compilation. Whereas here, what happened during the compilation, is the memory allocated for integer a?
Sir, I have a sir.
Yeah, yeah,
So I have a doubt. So for suppose we have written .sv file, and whatever the constructs or that we have written inside sv.sv file, or that we use in Verilog.
yeah,
So when a .sv file compiles, no, so is it
yeah.
like all variables are dynamic? It is that like they
No, no,
differentiate between .sv and .sv?
no, no, not like that. See, I did not say integer is static. I did not say integer is dynamic. It is the dynamic array is what is making it. See, even here, if you write integer, integer b is static in nature. Here, it's not the integer which is giving dynamic nature. It's the dynamic array is what is giving the dynamic nature. Have you understood?
Oh yes, sir. Yes, I got it.
Okay.
It means like only few variables are dynamic. Is that
I told you, right?
or
SV is a mix of static and dynamic. See, there will be around 10 to
okay?
15 things which are dynamic in nature. System Verilog has around 15 elements which are dynamic in nature.
Okay.
If I have to tell you the list, okay, mailbox is dynamic, dynamic array, queue is dynamic, cover group is dynamic, class is dynamic. Like that, there will be a list, okay. Other than that, the rest all things will be static in nature.
Okay. Thanks.
Now, let us try to understand what is better. Static is better or dynamic is better? Which one is better?
Dynamic is
Static
better.
or dynamic? Tell me why dynamic is
Dynamic
better.
because it only uses memory when it is required.
Exactly. Yes. So basically, in dynamic memory, what you can do is, let's say you go back to dynamic array. I have this is how you declare a dynamic array. When you want to allocate memory, what do? You allocate memory. If you don't want, let's say you can fill int a of 2 equal to 25, int a of 3 equal to 32, like that you can fill. Now when we once we are used once we use this used array, and we anymore don't want array, we can delete. If all you have to do is int a equal to new int a dot delete, that's all. Array elements gets removed, array elements gets deleted, array elements gets deleted. It is not possible with static array. If I take a static array like this, let's say, how do I tell static array? Y5 int 9 down to 0. What type of array is it? Is it dynamic or static array? When I say 9 down to 0,
Static. Static.
it is static array. What tool will do is, tool during the compilation allocates 10 integer space, 10 into 32-bit space for this array. Tool during the compilation allocates 10 into 32-bit space for this array. Now, in that case, I don't need line number 50 because you have already allocated 10. The problem here is this size cannot be changed. This size can't be changed. You can't even increase this size. You can't even decrease this size. Because once you have declared 9 down to 0, it is static in nature. Static means what? It will exist till end of the simulation. This memory, this 10 into 32-bit memory exist till we end simulation. What is the problem? Even if you don't want, you can't delete it. Let's say if you don't want memory, we can't delete it. We can't delete it. So tell me, which one gives you better memory efficiency?
Dynamic.
Tell me everyone, which gives more memory efficiency? Dynamic array gives more memory efficiency because it's like my memory is fixed. Okay, when I need, I will allocate the memory. When I don't need, I will remove this memory. This part of memory removed. Now it is free. Whole memory is free. In static, the problem is once I have allocated, let's say I have allocated this part of memory, I have used this. This will exist. You cannot reuse it for anything else. Okay. So I hope everyone now understand dynamic is better than static. So Verilog has only static data types. If you see, Verilog has only static data type. System Verilog has static and dynamic data types. Now tell me, from a memory utilization perspective, which language is better? System Verilog is better or Verilog is better? It is System Verilog because it has got dynamic data types, which makes everything more efficient. Now, please do not think that everything in system Verilog is not dynamic. Okay, everything in system Verilog is not dynamic. Okay, that's what I'm explaining here. Please read this part alone now. Only that part only. Please read it, everyone. So I hope you have read through this. System Verilog has two kinds of data types: static data type, which is memory is allocated and fixed at compile time itself. Verilog only supports static data types. What is dynamic data type? Memory allocation happens at runtime. It can be increased. Now, what is the advantage with the dynamic arrays? What is the size I have given here? Tell me. What is the size I have allocated? 5 units, five elements, right? After 100 nanoseconds, after some 100 nanoseconds, let's say I need space of 20 integers. All I have to do is int a equal to new of 20. Now the size is increased. 20 elements. This is resizing is not possible in static arrays. Next, let us learn any language having dynamic data types is considered more efficient. It can be any language you take, whichever has dynamic data types is always considered more efficient from a memory utilization perspective. Now, before we go to the further aspects, okay, I think let's talk about these two things. The second topic we need to understand is the different types of data uses, different phases of data uses. Just color it.
Sir, your voice is breaking.
One second. Everyone is facing my audio issue. Everyone facing issue with my audio?
No, your voice is clear with us.
Okay. So those who are facing issue, please rejoin again because other people are able to listen properly. Okay. Next, in system Verilog, we need to learn different phases of data type uses. Generally in system Verilog, a data type can be used in 4 phases: definition phase, instantiation, creation, and randomization. What exactly does it mean? Let's understand through one example. When it comes to the definition can be a language provided definition, or it can be user defined data type. I will take few examples. Integer, is it language provided or user defined?
Language.
It is language provided. Byte, tell me, what about byte? Is it language provided or user defined? Byte is language provided. If you go to in system Verilog, there is a data type called as byte. Okay. Similarly, if I write nibble, basically it represents 4-bit data vector, 4-bit vector. Okay. It is user defined. User has to define this data type because the language doesn't give nibble data type. Okay. That means what? In the language, the data types can be 2 types. One is the one provided by the language. The other one is the user defined data types. I will give you some more examples of user defined data types. As you all know, System Verilog revolves around object oriented programming. System Verilog, the foundation is object oriented programming. Object oriented programming is nothing but classes. I mean, implementing everything using a class. Let us say if I declare class Ethernet frame or mem transaction, bit 31 down to 0 address, bit 31 down to 0 data, bit write read. This is an example of a memory transaction. Means a class which holds all the information required to do a transaction. You need to do a memory transaction, you need an address, you need data, you need to tell whether you are doing write or read. So to do the memory transaction, you need address, data, and write read. This is an example of a user defined data type. See here, we are defining a data type by name mem transaction. If you take in this from line number 61 to 70, there are 4 data types we discussed. 2 integer and byte are language provided data types. 2 data types, mem transaction and nibble, are user defined data types.
Sir, the class that you have defined above, is it kind of looking like a structure, no?
Here class and structure are very similar. Okay. Class is an improvisation over structure. Like in C language has structures, right? So the class is improvisation on top of struct. Class is better than struct. Okay, that's why instead of using struct, we use class. Is that clear to you?
Yes.
Okay, now has everyone understood what is the difference between language provided and user defined data types? Okay. Next, the first stage in the usage of data type is learn how to define the data type. I mean, if it is language provided, nothing to do. Let's say if I ask you, my question is what? Declare an array of array of 10 integers. Declare an array of 10 integers. So what do you do? I will open the tool. I have to declare, if I ask you what is my question, declare an array of 10 integers. Now, do you need to define the data type? No, right? You can directly start off with using the integer. So module top n module integer int array of 9 down to 0, something like this. For next question you have to ask is this static or dynamic in nature? Whatever you are declared, integer int array 9 down to 0, is it static or dynamic? It is
Static.
static in nature. So if it is static in nature, memory is already allocated. So since it is static, memory is already allocated during the compilation. All you have to do is you can directly fill the array, initial, begin, end, for integer I equal to 0, I less than 10, I equal to I plus 1, begin, end. I have to say int a of I equal to some value, let's say dollar u random range 30, 50. What am I doing here? I am filling the array elements with values between 30 to 50. It can be anything between 30 to 50. I am populating the integer array. Now I can display this integer array by using int a equal to percentage p. Now let us try to understand how system Verilog makes the coding easier. See, this is how we would do in Verilog, right? In Verilog, even this is not allowed. You have to write, you have to declare again here integer a, integer I you have to declare, right? This is also not possible. If you come to system Verilog, what you can do is you can just replace this whole thing with, for each int a of I. Then you don't need to declare integer I. Let's try to understand how things are improved in comparison with Verilog. See, line number 6 is an improvement because you don't need to write, we don't need to write the range of I. The tool will automatically figure out. When you say for each, tell me what is the range of I tool will automatically go through. When I write for each, what do you think tool will use the value of I for? Where does it start with? It will start from, actually it start from in this side, 9 8, like that it will go. It will start from the left hand side and it will go down 9 8 7 6, like that it will go. You all understood, everyone? Now this is another improvisation. Mean this is percentage p. Like what is percentage b is called as? Why do we use percentage b? Why do we use percentage %b? Can you tell me? For binary format printing, right? So percentage %h is for hexadecimal printing. The same way, percentage %p is used for packed printing. Please tell me, everyone, why do we use percentage %p? I want everyone to answer. It is used for packed printing. Packed means what? Printing everything in one place. Printing everything in one place. So in that case, you go for percentage %p. So let us run this code now. Running this code is same as Verilog. First, what do? Vlog int array.sp. vsim top run -all. Do you see any difference between Verilog and system Verilog here? Between Verilog and system Verilog, except for this file extension, do you see any difference? No, right? That's how it works. All you have to do is what? Do run.do. Now I don't need waveform. You see now the array got populated. What is that you notice in these values? All these values are between 30 to 40, 30 to 50. So this is the third improvisation. I mean, if you want to assign a values in a range, you can just directly use $urandom range and you can write 30 to 50. Have you all learned this in Verilog? Has everyone have you all learned what is $urandom range during Verilog? Okay, good. So these are the improvisations. Now, if I ask you one question, that declare same thing, do the same thing for byte array. If I ask you to do the same thing for byte array, what will you do? Byte array .sv. I will copy the same code. I can replace this integer instead of integer. What I will use? Byte. I can directly use byte because this comes with the language, and I can run it. If I now instead of int array, if I write byte array, it will go through. See here, if I run it, you see it goes through. But if someone tells me declare a nibble array .sp, it won't go through. Let's say I will call it as nibble array. Wherever it is there, you write nibble array, nibble array. It will not go through. Reason is the system Verilog doesn't have a data type called as nibble. System Verilog doesn't have a data type called as nibble. So if it doesn't have, if there is no language provided data type, what is the solution? Can you tell me? If language doesn't provide the data type, what is the solution? If language doesn't provide the data type, what is the solution? What should I do? User should define the data type. So I am going to define the data type now. So for that, the concept we use is called as type def. We are defining the data type. See, type definition, data type definition. Do you understand what is type def stands for? Type def means data type definition. In short, type def. So I am going to define my own data type. That what is the construct do I use to define the user defined data type? What construct do I use? Can you tell me? we will use type def data type. So let us use type def. So first thing I'm going to do is I'm going to write type def.
Sir, uh, hello.
Yes, please tell me.
So I have a doubt before proceeding this. So here,
Yeah,
when you display, right, nibble here,
yeah.
normally, if you go to the previous program, I think you have overwritten it. So when we print like percentage p, right, though the data type is byte, yeah, this
Yes, please tell me.
earlier you have declared a byte, no,
Yeah, I
instead of
understood.
integer it
Tell
was
me.
byte.
Yeah.
Yeah. So when you even if you type percentage p, right, all the data that are printed are in integer format, right? So how do we
Yes,
print
that
like
is how.
binary? Uh,
No, you don't have that option. See, percentage P in QuestaSim, if you're working with QuestaSim, percentage P always prints all elements in integer, integer format. If you go to, let's say, Synopsys, VCS tool, percentage P prints all integers in decimal format. Sorry, decimal format. Here it will print in hexadecimal format. It is the tool standard. In QuestaSim, the default everything when you use percentage P, everything is printed in decimal format. In VCS, same percentage P will print in hexadecimal format. I don't know
okay.
about NCSim. Is that clear to you?
Yeah. And one more doubt I have. So you're saying like data memory allocation, right? Generally, when we run simulation, right? Sometimes we compile it when we compile it, and sometimes we elaborate it, right? That time no memory gets allocated, right? Only when we simulate only the memory gets allocated. Is that?
See, memory allocation is something you cannot see. Can you see what is happening inside your laptop now?
No.
No, right? Generally, what happens, since you cannot see uh, what happens for static data types, when you compile, the memory already got allocated. But you don't see because memory is something very abstracted inside your laptop, it's there. So if you use some applications and see, you will see the memory allocated actually during compilation.
Compilation, we are not doing any sims, no. When we are not running any simulations, right? That is my question.
Even if you don't run any simulations, during the compilation, the memory got allocated for static data types. That's the nature of static data types.
Okay. 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 Thanks.
Okay.
Thanks a lot.
So now we will go to nibble array. So I told you that since language doesn't provide nibble data type, I have to define my own data type. Nibble is what? 4-bit variable. 3 down to 0. You write nibble. Now nibble is a data type. Now I can use it. So nibble is a user defined data type. Now this will work. Here if I go and write nibble array, just run it. You can see it is giving you a different set of values. One more thing. Are you familiar with the concept of seed in Verilog? Is everyone familiar with the concept of seed in Verilog? Okay. How we used to use seed? We used to call it as dollar random. In the brackets, we used to call seed. In seed in Verilog, how we used to use integer a equal to dollar random. In the brackets, we write seed. This is how we used to use. System Verilog is again improvisation on top of Verilog. System Verilog also has a concept of seed, but it's a lot easier now. I don't have to do this now. I don't have to go through this complex process. You know, right? Was it easy? It was little difficult, right? You have to read the argument. That argument you have to pass as a dollar random argument. It is little difficult. System Verilog makes the things easier. How it makes the things easier is all you have to do is just go and write here hyphen sv seed some random value. No need to do anything else. No need to do anything else. Seed takes effect automatically. Now my simulation will run with this seed value. Now if I run, my randomization will come with a different set of values. Do you see both of them are the same or different? Are they same or are they different? Different, right? Now, if I go and again change the seed, I change the seed. Again I run. Is it same or different again? Different. Now tell me which language is easier? Verilog is easier or System Verilog is easier? So going forward, you will learn that System Verilog is nothing but Verilog. System Verilog is same as Verilog with some improvisations. Basically, how we can do the things better and in easier manner. You understand, right? What I mean by easier manner? For example, tell me, this is easy or not? The way I am printing, is it easy or would it be easy in Verilog or System Verilog? Using percentage p is easy or writing a for loop? Again, you write int j equal to 0 to 10, then you write dollar display. Which is easier? Verilog is easier or System Verilog is easier? System Verilog is easier, right? Next, writing for each is easier or for loop is easier? Which one is easy? Tell me. For each is easy or for loop is easier? What is the advantage of for each? It automatically gets the range. Let's say even if you write 7 down to 2, let's say it is possible actually. This is possible. 7 down to 2 is possible. You don't need to tell. Tool will automatically figure out that index starts from 2, it will go till 7. If I run it now, how many elements will print? Can you tell me? How many elements do you think will print now? 6 elements. You can see that now. The 6 elements being printed, you can see. In Verilog, it is not possible. In Verilog, you have to write what is the starting index, what is the range, everything you have to write. In System Verilog, you don't need to do. Now tell me, is this better? Isn't it is improvisation, right? It is a better way of doing the same thing. So the point I am trying to tell you is that do not think that, always think that System Verilog is easy to learn. If you start with the assumption that it's very complex language, it will be very difficult to learn. Actually, it is not complex because I have told you it is just improvisations on top of it. Next. This is about how to display. Now, I can use for each here also. I can use for each here also. I can write nibble array of I, begin, end. I can do dollar display the way I would do manually in Verilog. I can do here also. I can write I equal nibble array of percentage 0d is equal to percentage 0d. Now, if you want binary, you can print binary, and you can write I comma nibble array of I. Possible. Now I can run this again. See, 7 down to 2 it's printing. Basically, what it does is it's printing in decimal, this it's printing in binary, because we gave that format only. We said I want decimal, next one I want binary, and you see how the I got printed. It goes from left to right, 7, 6, 5 up to 2. You can see that here. 7, 6, 5, 4, 3, 2. Next. So this is about nibble array. I hope by now you have understood what is meant by language provided, what is meant by user defined data type, and you all know what is meant by instantiation. Now let's talk about creation. The third step in the data type usage is called as creation. What is creation here refers to is if data type is static in nature, no need of creation. Because why? Since memory is already allocated. Memory is already Since memory is already allocated, there is no need of creation. Whereas if data type is dynamic in nature, we need to do creation. We need to create. Do you understand the difference between static and dynamic data types? If a data type that you declared is static in nature, no need of creation because memory is already allocated. Whereas if it is dynamic in nature, we need to create. So how do we create? We have to, for that I will take one integer dynamic array. I will take example. I will take the same as previous one, integer array. First thing is to tell that something is dynamic, you should not keep the sizes. If you don't give any sizes, this is called as dynamic array. Same thing if you write a dollar like this in between, it's called as a queue. System Verilog has various types of arrays. If I give a size from 9 down to 0, any number, it's called as static array. One more entry will be there like that. Star if I give, it's called as associative array. Now, what exactly is dynamic array? What is queue? What is static array? And what is associative array? We will discuss as we go forward. Let us, for now, not worry so much because I was introducing you to this, so I thought let me explain you everything. When you use dollar in between, it is called as queue. When you use some fixed number, it's called as static because it got fixed already. When I use star, it's called as associative array. Okay. Now tell me, is it a dynamic array? Is it a queue? Is it an associative array? What exactly? What did I declare? Tell me.
Dynamic.
What is the data I declared now? I have declared a dynamic array. Now tell me, do I need to, is the memory already allocated or do I need to allocate the memory? Is the
Need to
memory
allocate.
already allocated? We need to allocate. So to allocate the memory, I have to write int a of new square bracket. How many elements you want to allocate? Let's say I want to allocate 10 elements. So allocating 10 elements. Allocating 10 elements. So for each, rest all things are same. See, when you use dynamic array, this is the additional step. Rest all things, no difference at all. I can run as it is now. In dynamic array. Now you just go ahead and run it. See like this. You may ask, what is the advantage? It is code is getting increased. What is the advantage? Now you will see the advantage. Let's say I want to increase the size. I can just do that. Int a equal to new of 20. Now if I display, tell me how many elements will be there? Tell me, line number 16 will print how many elements? 20 elements. It's not going to be 30 because you said I want 20 elements. It's not going to say 10 plus 20. It's going to do only 20 elements. If I run, it is keeping 20 elements. Tell me why it's giving X for everything. Why is it giving X? Why is it
We have
printing X?
the random is before declaring,
No,
right?
no, no, it's not like that. Yeah, because when you did new, what happened is it erased this. It erased the existing entries and it is creating a fresh memory. Erasing existing, freshly allocate. So when you allocate, what is the each element of array? It is an integer. What is the default value of an integer? What is the default value of an integer? X is the default value. See, had it been int, default value would have been 0. For integer, the default value is X. So because of that, it is coming. This thing can be done in a little different manner. Now, the same thing if I write int a, let me do. What this will do is, this line is different. This will retain existing elements of int a and only create new elements. Only create new elements. What does it mean? See, int a already has 10 elements. So those 10 elements will exist. Additionally, only create 10 elements. Do not allocate memory for initial 10 elements, because by writing this in the brackets, you are telling what? Copy the existing integer array. Retain those existing elements of integer array. Only create the new elements. Now if I run this, what is going to happen is this initial 10 access will not be there. These values will come. Later 10 only will access will come. Wait. Oh, here I have to comment it out. You see what happened? 20 elements are there. Out of them, first 10 elements are initialized. Later 10 elements are all X. I think I know things are getting a little complex here, but it gives you more convenience actually. Now you can't do the same thing so easily in Verilog actually. You can't get similar behavior so easily in Verilog. See, here it's very easy. If you don't want to retain, you just do new of 20. If you want to retain, in the brackets you write int a. It will retain. See what it's doing. We are resizing this array to 20 elements. You have two options. One is recreate everything. One is retain 10, create 10 freshly. You have both the options. Now, as a person who is learning system Verilog, you need to learn these techniques. How to create freshly, how to create while retaining. Now I can even downsize. The array. Let's say I want to downsize it to 4 elements. Now the question comes, same thing. Do you want to retain or you don't want to retain? Downsize means what? 20 elements. I want to reduce it to 4 elements. Now the question is, do you want to retain the existing entries or do you want to create freshly? That's the question. So now in this case, tell me, will it retain or will it create fresh entries? Whatever I did now, what it's going to do? If I do this, will it retain the existing entries or will it create a new array? This will retain. You see now. See, it is retaining the first 4 elements. If I don't do this, fresh entries. What will print? Tell me if I run now. Instead of this, what will be printed? Can everyone tell me? In the updated one, what will be printed? All X's are printed. So you can see that now I'll ask you one question. Which array is better? Static or dynamic? See, your programming requirements keep changing, right? So where sometimes you want to increase the size, sometimes you want to decrease the size, all that. So all that perspective, dynamic array is better. So that is where you see that system Verilog is improvisation of what is there in Verilog. System Verilog is nothing different. What is it? System Verilog is not anything different. It is just an improvisation of what is there in Verilog. Next.
Sir, out of curiosity, I'm asking. So, like you're deleting the last entries, right, all the time. So, will it be possible to delete the first entries or from first and last entries? So, can keep in the middle entries like that?
No, directly you cannot do. You have to find a different way of doing it. This kind of thing will not allow you. But you have to use some for loop or some other way of doing it.
Okay.
Okay. Next. This is about creation. Have you understood what is the language construct do we use for creation purpose? Can you tell me, everyone? What is the construct that we used for creation? We use the method new. Okay, then there is something called as randomization. Fourth stage in the data type uses called as randomization. Let me not talk about it today. Later we'll discuss that. Okay, then we'll move on to, since we are done with this, let's move on to the next topic, that is constructs and pre-implemented methods. See, in Verilog doesn't have pre-implemented methods except for system tasks. Whereas in system Verilog, every construct has lot of pre-implemented methods. What does it mean is, let's say, are you familiar with FIFO in Verilog? Are you all familiar with FIFO in Verilog? Yes, right? Now, was it provided in language? Was it provided by language? Or was it developed from scratch by user? The FIFO in Verilog, did we develop or did we use from language? It was developed, right? We developed FIFO. It was. It takes. How much time did it take? Tell me. Can you tell me how much time you took? Code. Someone is telling two. What is two? 2 seconds, 2 minutes, 2 hours, 2 days. Tell me. Tell me. How much time did you take? You tell me. You know, right? You did that project, right? Isn't it? Tell me how much time you took. That means except Sushma, no one else developed FIFO. How about others? Only 3 people are responding. Okay, let's say people are saying 4 hours on average, for example. Like someone is saying 2 hours, 3 hours, 4 hours, 2 days. Let's say 4 hours. In system Verilog, No need to spend any time. No need of any time. No, the language itself provides. So basically, we save that 4 hours. That is essentially called as mailbox inbox. You can write anything: mailbox ABCD, mailbox XYZ, mailbox inbox, anything you can write. Now you may say, what is mailbox? Why don't they call it as FIFO? You may say, why don't they call it as FIFO? If they are implementing FIFO kind of behavior, why don't they call it as FIFO? It's just that they decided that they will call by name mailbox. How mailbox works, let's take an example. At your house, you put a mailbox here. The postman drops mails. What will happen? The first post that he dropped, you will pick from here. Second post he has dropped, you pick from here. Okay. The third thing he dropped, you pick later. So do you understand how mailbox is working? You put in this order, you get in this order. So what is this kind of behavior? Is it? It is a FIFO kind of behavior. But it was easy to understand it like a mailbox where mails are dropped and mails are picked. That's why they have given the name mailbox. Okay. Don't get confused by the term mailbox. It's not a complex term. Mailbox, a very similar to FIFO. Now, tell me, going by this context, Verilog is better or system Verilog is better? Why is it better? Tell me in this perspective, why is it better? We don't have to spend this 4 hours time to develop it because language itself provides it. Not only this, it provides you with methods. Like if you want to put something to the mailbox put method. If you want to get something from mailbox, get method. If you want to delete the elements, just say delete. If you want to allocate a mailbox to hold 20 elements, like this. Let's say let's say take your house. Let's say there is a post box here. Okay. Do you think can it hold 1,000 posts? Imagine a mailbox anywhere, right? If not at your house, any house, can it hold 1,000 posts? No, right? Maximum it may hold up to 20 posts. Same way, you can define what size you want. When you create the mailbox, you can tell how much size you want. It is similar to, what is it similar to in FIFO? What is this concept is similar to in FIFO? What is that we used to call as for FIFO? This 20 in FIFO, what we will call as? Depth. You remember the term depth? It's called as the depth. Okay. So the important thing in system Verilog is that lot of structures are pre-implemented. System Verilog, lot of things are pre-implemented. Lot of constructs are pre-implemented. User only need to learn how to use those methods. User only needs to learn how to use it and how to use the methods. Let's say it comes with various methods like put, get, delete, various methods. User only need to learn how to use these methods. Okay. Similar to that, if I use a queue, if I talk about a queue, see mailbox has some other methods like try put, try get, peek. I will not talk about them because I don't want to confuse you with too many things. Okay. Now let's take a queue. Similarly, system Verilog also has a new construct called as queue. How do you declare a queue? Integer int q dollar. So queue in system Verilog comes with lot of pre-implemented methods. What are the methods typically when you use queue? What do you want to do? Tell me. Imagine a theater queue. You go to a movie, there is a ticket counter, there's a queue of people, right? There's a queue of people. Typically in this queue, what do you want to do? What all things you would like to do with this queue? Tell me. Just let's see how much you can think about this question. I'm not talking about system Verilog here. I'm not talking about Verilog here. I'm talking about a theater. Let's say you go to a movie today, and what do you want to do in queue typically? Sometimes you are in urgency. Sometimes you are in urgency. You want to get the ticket before everyone, so you can go to the front. So that is called as push front. Push a person into the front of the queue. You agree? Push a person. I mean, you are pushing a person inside into the front of the queue. Now, one person has already taken the ticket. He wants to come out. That is called as pop front. Popping the element from the front. Generally, when you go to the queue, where will you stand? Where are you supposed to go? To the front or to the back? In the general scenarios, where do you go? No, generally, where will you go? If already there is a queue, where will you go? To the back. So that is called as push back. You're being pushed into the back of the queue. Next, you see that line is very long. I don't want to stand. So you want to come out. That is called as what? You're coming out from the back. You're coming out from the back of the queue. What is that called as? See, theater, the queue is already very big and you don't want to wait for so much time. You want to come out. What is that called as? It is called as pop back. Okay. You are already standing. One of your friend is coming. Let's say your friend wants to come. Where will he come? Will he stand here or he will come here? Mostly you will come and ask him to join here. That is called as insert. Now, one person here in between wants to come out. Tell me, you understood? One person somewhere in between the queue wants to come out. What is it called as? Tell me. That operation is called as delete. Next, this theater manager wants to know how many elements are there, how many people are there. That is called as the size. Like this, various methods are there. Other than that, you can also do something called as reverse. Next, what you did, what you told is this is not the counter, this is the counter. Everyone reverses. This person gets the first. That becomes reverse. Next, once reverse is done, what else? Last thing you can do is shuffle. Shuffle means what? You ask all of them to move in random order. That is called a shuffle. Okay. So what System Verilog does is System Verilog thinks about all these possibilities. The people who have implemented System Verilog, the people who implemented System Verilog has thought of all these possibilities and they provide all these methods. User just needs to learn how to use these methods. Now, let me ask one thing. What is the first method we discussed? Tell me. With respect to queue, what is the first method we discussed? Push front, push back, pop front, pop back. What were the other methods? Tell me. After push and pop, what were the other methods? insert. After insert, what was the method? Delete. Then the manager wants to know how many people are there in the queue. How will he get? How he gets to know what is the number of elements? Size. I want to arrange all of them in a random order. I want to arrange all the people in random order. What will I use? What method do I use? I want to arrange all the people in random order. What method do I use? Shuffle them. Shuffle. It's like shuffling the cards, right? Then what is the last method? You want to reverse the people. Whoever is in the end, he should become the first person. Whoever is in the beginning should become the last person. What do I do? Reverse. So that is how the various methods are implemented. Like that, the system Verilog has various methods. Dynamic array is a construct. It comes with methods new, num, delete, shuffle, reverse. Class comes with various methods. So for now, let's not get into everything. All you should remember is like mailbox comes with what all mail methods we are discussed about mailbox. Can you tell me? Like for queue, we discussed various methods. What all methods did we discuss for mailbox? Put, get, and delete. And new was one more method. Okay, so these are the things we discussed. Okay,
Sir, I have a doubt.
now
So it
yeah,
seems like, sir, it seems like
yeah.
queue is like little more advanced than mailbox. Then what is the use of
Of course,
mailbox? Because everything we are whatever we get
mailbox.
in the mailbox.
No, see, this put and get are tasks. These all things you see here are functions. Okay, these are functions. Some of the requirements only tasks can fulfill that. Functions cannot fulfill some of the requirements. So in those cases, we use mailbox. Now, what exactly is that? We'll discuss later. You understood? Put and get are tasks. And whereas in a queue, everything is a function. Pushback is a function, push front is a function, pop back is a function, insert is a function, everything is a function. So there are some requirements which functions cannot fulfill. You cannot use functions for those requirements. There you only need to use task. In that case, you go for mailbox.
Okay.
Did you understood?
Yes, sir. Yes.
Okay. Yeah. Let us do one thing, everyone. We'll take a 10 minutes break. So we will meet at 1:20 p.m. and then we'll continue the session. Okay.
This conference will now be recorded.
Okay. So till break, we were discussing about queue, and more importantly, we were discussing about the concept of constructs and the pre-implemented methods. So from a user perspective, you don't need to learn. You don't need to learn how system Verilog implements mailbox. You don't need to learn how system Verilog implements mailbox. You only need to learn how to use mailbox. That's all. What are the methods of mailbox and how to use those? Same way, the same question again, that you don't need to learn how system Verilog implements a queue internally. I mean, the queue system Verilog internally language will implement it in its own way. You don't need to learn that. You only need to learn how to use queue, how to use methods of a queue. That makes it very easy because in Verilog, had it been Verilog, there is a one bigger thing we had to do. We need to learn how to implement mailbox. See, in Verilog, we also need to learn how to implement the construct. which is not there in System Verilog. Hence, System Verilog language is lot easy compared to Verilog. Now, let us do some examples on to learn how to use mailbox and how to use queue. Okay, idea is not about mailbox, idea is not about queue. It's about how to use the pre-implemented constructs. Mailbox. Now, there is no need to give it as mailbox. I can give anything. I can give name as XYZ. Just because you can easily correlate, I'm giving the name as mailbox.sv. Do not think that it is compulsory to name it as mailbox. Okay, you can name anything. Now, module top, in module. What I have to write here? Since it is mailbox, I have to write mailbox. You can give any name XYZ, but just for my convenience, I give the name mbox. Now tell me, mailbox. First thing you have to ask is it static or dynamic? Tell me. Can you tell me, is mailbox static or is it dynamic? It is dynamic. If it is dynamic, what is the first thing you have to do? After instantiation, next question, is mailbox language provided or user defined? Is mailbox language provided or is it user defined? Mailbox is language provided. So here I'm instantiating. This is called as instantiation. After instantiation, what do we have to do as per this? Once you are done with instantiation, what is the next step? It is language provided. Then you have done the instantiation. What is the next step after instantiation? You have to create. Create means what? You have to allocate the memory. How do you allocate the memory? What method do we use to allocate the memory? We use new method. So we do what? Mbox equal to new. Now the question is can I do like this inside this code? Is it possible to write like this? What kind of statement is it? Is it continuous assignment or procedural statement? Tell me. What type of statement is it? Mbox equal to new. What type of statement is it? Is it continuous assignment statement or is it procedural statement?
Continuous assignment.
No, 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 no. It is procedural statement. If I write assign here, then it is called as continuous assignment. Now tell me this procedural statement. Where do I have to write procedural statements always? Inside what it should go always?
Always or initial begin.
Either always or initial block. So I have to write initial, begin, end. So if you write like this is wrong. This code, what you see here is wrong because I cannot write it outside initial block. This is correct. What I have done now is correct. So I'm done with the allocation of the memory. Now I can use the mailbox. I can use mailbox methods. Let us say. Now you may say, what is new of this means? Earlier I taught you where I said that if I give mailbox equal to new of 20, how many elements can it hold? When I say new of 20, how many elements can it hold? It can hold up to 20 elements. Whereas if I give like this, tell me how many, it can hold up to how many elements? Infinite elements. It's not zero. Answer is not zero. If you wanted zero, you would have written zero. If you don't give anything, it takes as a number as infinite. So these are the few things you need to remember, and as you work, you will get used to it. As you start working on System Verilog, you will get used to it because these are the things you do every day. So you will learn automatically. Okay, no, nothing to worry.
Uh,
Now,
sir, I have another doubt.
yeah,
Sir, sir, if you
yes,
say
ask.
like a mailbox is equal new and like brackets without mentioning any number, so does it throw an error? System throws an error
No, system doesn't take any error, throw any error
because you are
because
saying.
no, no, wait. I will tell you. System verilog functions supports a concept called as default arguments. If you don't pass any argument value, they will take infinite as the value. There is such a concept where they take the default arguments. It's like simple example I'll tell you. Are you familiar with have you understood the concept of default arguments in Verilog?
No, sir. No.
No. Okay. See how it works is if I write function void or whatever, let's say int some input int a equal to 10, input int b equal to 20. So here the concept is that if you don't pass, let's say I'm calling c equal to sum, it will work. Can you tell me what will be the value of c in this case?
I don't.
What tell me what will be the value of c? So sum means, of course, you are telling your idea is what? Return uh, a plus b. That's what you want to do. Tell me what do you think it will take? It will return 30 value. It is because even if you don't pass, it has got something called as default arguments. If you don't pass, a equal to 10 it will take, b equal to 20 it will take. Next, if I pass 1 comma 7, what will be the value? C
8.
will take 8. If you pass 1 only, what it take? Tell me. Will it work?
It works and it is 21.
It will take 21 because what it will do is 1 it will take for a. Since b you are not passing anything, second argument it's not taking, it will take 20. Okay, next. If I pass comma 2, what it's going to take? Tell me. What will be the value?
11. 12. 12.
12 it will take because before comma you haven't passed anything. Before comma you haven't passed anything. That it will take for 10. So 10 will be taken as default value. 2 you are overriding. You are telling that instead of 20 I want to pass 2. So 10 plus 2 is 12. This is the concept of default arguments. If these two arguments were not there, then this and this wouldn't work at all because it becomes compulsory for us to pass the arguments in that case. Something similar happens in case of mailbox also. Have you understood?
Not clear
Have,
actually. What I'm thinking is like when the size is infinite, right? It has to allocate the infinite memory. So anyhow
it
we
won't
don't have that
allocate.
infinite.
No, no, it won't allocate. See, it's like telling if you take a example of a theater queue. Okay,
Hmm.
if I tell that size of queue the 1000. Okay, let's say it can accommodate up to 1000 people. Does it mean that anytime you go, will you find 1000 people there?
No.
No, right? If there are 5 people,
Hmm.
the size is 5 only. But it can be extended up to infinite. Now, technically speaking, there is nothing called as infinity. What is infinity? It comes down to my laptop RAM size. My tool is running in my laptop RAM, DDR. DDR, let's say, is 4 gigabyte RAM. That much space it can accommodate up to maximum. Beyond that, my laptop will crash. Have you understood? So it can go
Yeah.
up to whatever is the memory available. There is nothing called as infinity. There is no infinity in world.
Yeah. True. After this statement, right? New. Then if there are any other like variables, right? So they also need to get memory, right? So if there
No,
is no
not like
memory,
that. See,
whatever the 4
understand the
GB
point.
RAM.
understand the point. When I say infinite, it's not going to allocate 4 gigabyte. Say as the people keep coming, the queue size keeps increasing. Same thing will happen with the mailbox. As initially mailbox will have no element, zero element. When you put one element, one memory gets allocated. When you put two elements gets allocated. Like that. When you give new of 20, the limit reaches at 20. After 20, it won't take new elements. Whereas when you just do new, you can keep putting any number of elements. That's the difference. Initially, it didn't allocate any infinite memory, or it didn't allocate 4 gigabyte memory. It allocated only no element space. As you start putting, the memory keeps getting incremented.
Okay.
Did you understood?
This time, yeah, yeah, got it. But this time I'm remembering a concept called like continuous memory allocation. Like, for suppose we have a 8 bits, right? For suppose we have declared 8 bits,
Yeah,
no? Now each
yeah,
bit, each memory is like one after the another one. For if one byte is allocated at memory location one, next byte at two,
yeah.
next byte at three, memory location. Uh, Sometimes one bit allocates at one location, second bit allocates memories at some second location. So I heard this.
No, why?
Uh,
What is that? It has to do with mailbox. Please tell me.
yeah. Uh, I'm like I'm a little unclear, but what I'm thinking is like when we
No, see,
have suppose when we keep on adding the mails,
yeah,
when we keep on adding the numbers, right?
yeah.
So at one location, suppose one bit, I mean stored at one location one, at second bit location stored at location five, at third bit stored at location eight. So it is not like continuously they are one after one, two, three. It's not allocated like that. Or
Let it not allocate, then it will create a linked list out of those elements.
okay,
It
okay,
internally create linked list. My tool will do that. I don't have to worry about that. My tool will take care of everything.
okay,
That's why
okay.
we are
Got it.
paying crores of monies and purchasing the tool. The tool doesn't come for free. Tool comes at a cost because they take care of all those things for us.
Okay.
Okay.
Oh, thank you.
So when I say mailbox equal to new, it is not doesn't mean that right now zero elements are there. If you, same thing we'll notice here also. If you go here, if I do let's say int a equal to mbox dot size to dollar display of a. What do you think value of a? Will a be 0 or infinity? Can you tell me what will be the value of a? Can someone tell me what will be the value of a?
It should be zero.
It should be 0 because you haven't allocated anything. So size, okay, it's not size, it's num. Okay, mailbox dot num. A is 0. Now let us say into the mailbox, let's put some element. Put some elements. How do you put mailbox dot put 25? Mailbox dot put 16. Mailbox dot put 109. Now if I get the size, tell me what is the size? Can you tell
Should
me?
be three. Three.
It will be 3. That is why mailbox is called as, you see, a equal to 3. It is that's why mailbox is called as dynamic data type. As you start putting, the size keeps increasing. Now if I remove, let's say, get some elements. How do you get? You write instead of a, you write b here. B equal to mbox dot get. I should not use like this. I should use B in the task itself because get is a task. So it won't return. The output will come as a return argument. I mean, as output argument. So do dollar display. Tell me what should come. 25 will come or 109 will come. Tell me.
Yeah, it should be 109 generally because whatever it's kept last time should come first.
No, mailbox is like a FIFO or LIFO. Mailbox behaves like a first in, first out or last in, first out. Tell me, everyone, what value should come out? If it is FIFO, what value should come out? 25. Okay. Next, what value should come out? What should be the next value? 16, right? Now, if I get the size, what do you think is the size will be? Tell me. What will be the size here? Line number 26, what will be the value?
1.
1 will be the value. So you can see the same behavior here. So the point you need to notice is that size is not going to be infinite. Infinite is like you can put as many elements you want. There is no limit. That's what you have to understand it like. You can put as many elements as you want. Now, how internally mailbox stores the values and everything, we don't need to worry about it. Okay. So this is how you use a mailbox. Next. Let's work with a queue.sv. I can use the same thing. See, I'm going to use the same thing just to show you that things are not going to be very different. Only thing is, since q, I have to write int, I can write int a of dollar. Tell me, do I need to make it q? Instead of a, shall I write it as q? Tell me. Should I keep int a or int q? Tell
When you
me.
keep
Should I
dollar,
change
it
it to int?
defaultly says that it's a keyword.
Yeah. So no need to write. You can write XYZ. This one. It is the dollar what is more important. Anything will work as long as you write dollar. But if you write int q and you miss the dollar, there is no use. Now tell me, what is it? Is it a q or is it a, what is it now?
Dynamic memory.
It's a dynamic array. It's not the name that makes sense. It's what symbol you use, what makes sense. Okay. I hope you have understood, everyone. Int q dollar. Okay. You can use any name. See, just for my convenience, I used q. Okay. Next. Now, even though q is dynamic, q is an exception. So even though q is dynamic, even though q is dynamic in nature, no need to use mu. Without using mu also, memory gets allocated. So this is an exception. See, it is an exception. Now let us learn how to use q methods. I want to get the size. So what is the method for a q? Tell me. Wherever mailbox is there, I will replace it with int q. Tell me. Instead of num, what should I use? I want to get the number of elements in the queue. What is the method that we learned? We have to use the method size. Tell me, what will be printed on line number 9? What will be printed on line number 9? Can you tell me?
0.
0 will be printed because queue by default gets created with 0 elements. Now, push back. Push back. Let's say push front. Tell me, in what will be the order of elements if I have to print? Let's say if I just do dollar display, int q equal to, I want to print everything at once. What should I use? Can you tell me? I want to print all the q elements in one place at one time. What should I use?
Percentage P.
Percentage p I should use. Now, what order this will print? Can you tell me? How these elements will look like? Will it look like 25, 16 like that, or what is the order it's going to look like? Everyone, can you tell me?
25, 16, 109.
It is going to look 109, 25, 16 because push front means it will go to the front. Then 25, then 16. Okay, next. Again, get the size. What is the size it will print now? Tell me. What size it's going to print here? Line number 17. It is going to print 3. Next. Can I use the get method? We can't use get method. What method I have to use? Pop friend I have to use. Pop friend. This b will not come in the argument. It will come in the beginning here. B equal to, because function returns the value. So b will come here. Here also same thing. B equal to. So here you have to use pop friend. Next, again do the size. Yeah, that's all. I can run this now. So I can go on say Q. Let's run now and just observe the values. 309, 25, 1. Okay. Have you all understood? Okay. Is everyone comfortable with the queue? Basic concept of queue. What is queue? Okay. So let us now learn the advantage of queue. How queues can make the programming easier. How queue can make test bench development easier, programming easier, or it's not test bench development, programming I would call it as. You remember in Verilog we had given one assignment to create an array of integers with no repetition in random order. Like it's like we told you create an array of 20 elements between 100 to 119, no repetition, random order. You remember this example? This is unique array example. How much time it took? Tell me how much time it takes in Verilog. Like you tell me roughly how much time each of you took to do this in Verilog. Okay. How about others? That means only 4 people did and other people didn't do at all. Okay, it took around maybe 1 to 2 hours time, right? Now let us see in system Verilog how it can be done quickly. Q random .sv module top in module int q dollar initial begin end. What you do is you need 20 elements, right? For int I equal to 0, I less than 20, I plus plus, begin end. Int q dot push back 100 plus I. Means what you are pushing 100 to 119. Do you agree with that? Have you understood? Line number 6, you are pushing values between 100 to 119 because I is from 0 to 19, so it will push 100, 101, 102 up to 119. Now all you have to do is you want random, you want the random order, right? You want the values to be random order. What do you think I should do? Tell me. I should use something. What is that I should do now? I don't want that order
Shuffle.
100, 101, 102
Shuffle.
like that. What should I use? Everyone tell me. I should use the method shuffle. Now just display. We already have that queue display, right? Let's just get it. Run it. Queue random. And let's run it. Can you see now? Is there any repetition? There won't be any repetition, and values will be random in order. Values will be random in order. Now let's say if you want different randomization, different random order, what do you do? Tell me, what should I do? Which line number should I change if I want to have a different randomization? Which line number should I change? Line number 2, and I have to change the seed. I can just use something else. Something else I changed. I just run again. You see, can you see the difference now? Okay, you see the advantage is what it took, what takes around maybe 30 minutes to 1 hour or 2 hours in Verilog can be done in 5 minutes in system Verilog. That is what is system Verilog. System Verilog, you have to learn from that perspective. You got it right. What is the advantage of system Verilog? How system Verilog more? What is the advantage you are getting? It is all this convenience is because of queue, because of queue and the queue methods. We are able to do. If the queue was not there, then it would have been difficult. If these methods were not there, it would have been difficult. Okay. Now, have you understood this concept of constructs and pre-implemented methods, everyone? Okay. Let us now move on to the next slide. Yeah, so we know how to work with static array, dynamic array, everything we know. The pre-implemented methods also I have discussed. How to use mailbox, put and get, everything we have discussed. Then I think this concept, let's not get into this. I mean, right now it's not very important. These are also not important. Good programming practices. I'll just focus on what is really important. Anyway, later we'll discuss those things. Okay. This is all fine. Arrays. Okay. Let us do one assignment and end the session for today. Okay. I want you to do this assignment. Please do this, everyone. Please start working on it. Okay. As you are done with this, you please post your answer in the chat window. So let us see how to do this thing. Okay. Uh, what is the question? Declare an array of word data type. Word means what? Reg 15 down to 0. Array size of 10. Fill array with random numbers between 20 to 30. So let's do this question now. Array compare. Let's say that what is that we are doing? Array compare finally. So what is that I want you to do? Array of word. Module top in module. Array of word, right? That means what? Bit 13, 15 down to 0. Or if you want, you can write reg also. Anything is fine. Word array 1. Size is what? 10 elements, right? I said 10 elements. So I hope you have understood how to declare it. Reg 15 down to 0 becomes a word. I mean, you may ask, word is English word, right? No, in VLSI, word means 16 bits, or in some cases it is 32 bits. For now, we are going with the assumption that it's 16 bits. Next. Second is what? Word 2, word array 2. Fill it with random numbers between 20 to 30. So how do you fill? You have to again write it as a procedural statement, initial, begin, end. Since I need to fill it, I have to write for each word array 1 of I, begin, end. Word array 1 of I is equal to between 20 to 30, right? You random range 20, 30. Similarly, word array 2 between 20 to 30. So till this point we have done. Have we completed second thing? Has everyone understood first and second step how we have done? Have you all understood how we have done the first and second step? Now let us do the third one. What is the third one? Write a logic to compare both the elements of the both the arrays. I want to compare both the arrays. So in Verilog, what will you do? You write a for loop, compare element by element basis, element to element. Agree, right? In system Verilog, we can do whole array compare. What is meant by whole array compare? I can write word array 1 is equal to word array 2. Word array 1 equal to word array 2. Then I can say dollar display, both arrays are matching. Else I can say both arrays are not matching. So this is not possible in Verilog. I cannot do the whole array comparison to another array in Verilog. In system Verilog, it is possible. I can compare one complete array to another complete array. So to run this again, what I have to do? I have to do array compare. Both arrays are not matching. Now I can do copy. So again to copy, let's say copy one array to another array. Copy array 1 to array 1 to array 2. How do I copy? Simple, word array 2 equal to word array 1. Then you again do the compare. Now tell me what message will come? Matching or not matching? What message will come? Can you tell me? Message that will come is matching, because we have copied one array to another array. So I hope everyone has understood till this point. Now the way you have done, you can do the same thing with string data type. See, till now we did what? Array data type. You can do the same thing with string data type. Can you see one? I mean, going to the before we go to the next question, can you see the improvement here? This is the improvement in system Verilog. In Verilog, it is not possible. In Verilog, it's not possible. In system Verilog, you can do whole array comparison is possible. So today itself, you see almost 7 or 8 ways in which system Verilog is better than Verilog. Next, let us see one more place where system Verilog is better. Now I want to do string data type, array of string data type. In Verilog, there is nothing called as string. I mean, you have to manually declare it. So here, if you see in system Verilog, if you have to do, all you have to do is string. Already language itself provides with string data type. That's all. Instead of word array, I'll call it as string array 1. Here, how I'm going to fill is, I'm going to use a new construct. You see here, I'm going to use a new construct called as dollar ps print. I think rather I leave it for now. This is the last thing I'm going to end with that. Okay. For now, I won't use such a complex thing. I'll use name percentage 0d I percentage g 0 d 0 percentage 0d. See what it's going to do is this concept. What it does is it will take this name percentage 0d. It will replace with I. So first time I is 0. So the name will become name 0. Second time I will become 1. So the name will be assigned, it will be name 1, name 2, like that. So this I don't need to do because both will match anyway. I can display names. See the advantage is I can display all the array contents just again in one line. Percentage S, sorry, percentage P, string array 1, string array 2, string array 2. I can do string compare. There is a problem. Dollar ps, okay, dollar ps print. Yes, instead of that I will use dollar s format. Dollar s format. Ps printf, I'm using it as a function. That's the reason. Yeah, I got it. That was a mistake. You can see it's taking name 9, name 8, name 7, name 6, like that, and both the arrays are same, so both arrays are matching. So the another improvisation is you don't need to declare string like in Verilog. What you would do, reg uh, uh, 20 into 8 down to 1, then string array 1, 9 down to 0. This is how you would do, right, in Verilog. This is not required in system Verilog because system Verilog gives you the string data. So a lot of such advantages are there working with system Verilog. Okay, so we will be ending the session here. So before that, I just want to confirm, have you understood this? I mean, this is how you would have done in Verilog because Verilog doesn't have a string data type. In system Verilog, you just directly write string and then you can write the array of that. Rest all things are same. Rest all things are same. Your PS, what does PS printf does is, it will take this one, it will convert this whole thing into a string. It will convert whole thing into string. You may say, why are you using PS printf? Why don't you give name I like this? What will happen? Tell me. What will be the problem if I give name I? Will it get replaced? Will I value get replaced? If I run this, what is going to happen? everything is going to get name I, name I, name I. Can you see? To avoid that name I just printing like that, what am I doing? We are implementing it as like this. Name percentage 0d will be replaced with the value of I.
Sir, I have a doubt. Yeah.
Yeah,
Sir, what is like instead of percentage zero D, what happens if you write percentage D?
it will give spaces. See, what it will do is it will print with spaces, because when it prints integer, it prints with spaces like this. Assuming that it's a 32-bit, it will print all those spaces. 0d means it will remove that spaces. Is that clear to you?
Yeah, yeah, clear.
So we will end the session here.